Peléan eruption, the one where a mountain erases an entire city in under a minute. There is a glowing cloud rolling down the slope, and the instinct is always the same. It is fog. It is smoke. It is something you can drive away from. People get in the car and hit the gas. They do not make it out of town. This cloud does not float. It hugs the ground because it weighs millions of tons. It is a pyroclastic flow, an avalanche of superheated gas and shattered volcanic glass, and the fastest of them pour down the mountain at close to 700 kilometers per hour, glowing at around 1000 degrees Celsius. It is the single deadliest thing in all of geology. On May 8th, 1902, this happened for real. Mount Pelée on the Caribbean island of Martinique fired one of these flows straight into the port city of Saint-Pierre. The town had seen weeks of warning signs, and it was never evacuated. In about 1 minute, roughly 29,000 people were gone. Out of the entire city, there were essentially 2 survivors. One was a prisoner, shielded by the thick stone walls of his cell, which is the only reason he lived. You do not outrun a Peléan eruption, you just become part of the ash it leaves behind, but at least fire announces itself. The next one turns the calmest thing on Earth into the trigger. Phreatomagmatic eruption, where water of all things becomes the detonator. You have seen the clips of lava pouring into the ocean, steam billowing up, and the assumption writes itself. Water beats fire. The sea wins. The boat tour is perfectly safe. The sea does not win. It amplifies. When magma at 1000 degrees meets water, the water does not politely boil. It flashes to steam in a fraction of a second, and as it does, it expands its volume around 1,700 times, all at once. That is not steam off a kettle. That is a bomb. The blast shatters the surrounding rock and throws out a shockwave, followed by a dense cloud of scalding steam and razor-sharp fragments that scours the surface like a giant belt sander grinding everything flat. Sometimes it does not just destroy, it builds. In 1963, off the coast of Iceland, this exact process erupted from the seafloor and kept going until it had stacked up a brand new island, Surtsey, out of open ocean. And at the far extreme, the 1883 eruption of Krakatoa, driven partly by seawater flooding into the magma, produced what is often called the loudest sound in recorded history. Heard nearly 5,000 kilometers away. Water is not the fire extinguisher here, it is the fuse. But if water can do that, wait until you see what a plug of solid rock can do. Volcanian eruption, a cannon with a cork jammed into it. People look at a crater that has gone quiet and sealed itself over and decide the volcano has finally fallen asleep. Some of them set up camp at the base. Sealed looks like safe. Sealed is the trap. Vulcanian magma is so thick and sticky that it hardens into a solid plug. A cork of rock wedged in the volcano's throat. The gas underneath has nowhere to go, so it keeps building, pressing against the entire weight of the mountain above it. When that plug finally fails, it does not leak. It detonates. The blast is literally supersonic, faster than sound itself. A shockwave flattens everything nearby. Blocks of rock the size of appliances fire out at ballistic speed, and a black column of ash punches up to 20 kilometers into the sky in seconds. Sakurajima in Japan does this constantly, sometimes hundreds of times in a single year. The city next door treats falling ash the way other places treat rain. Quick thing while we are here. If you are enjoying this, subscribe, like, and drop a comment. It is free and it genuinely helps the channel. Now, a cork is impressive, but what happens when the lid is made of ice? Subglacial eruption, fire clawing its way out from under a glacier. You look at a frozen, snow-capped volcano and it reads as safe by default. The ice is a lid, a thick natural shield holding the monster down. The calm feels permanent. The ice is not a shield, it is a dam. The magma melts the glacier from below, filling a hidden lake of meltwater sealed under the ice. Pressure climbs with nowhere to escape, until that dam of ice suddenly gives way. When it goes, you get 2 catastrophes stacked on top of each other. The magma meeting all that trapped water triggers violent explosions, and the released flood comes tearing downhill as a glacial outburst flood, what Icelanders call a jökulhlaup, a wall of water, ice, and volcanic mud that carries away bridges and roads like they were made of paper. Iceland lives with this. When Eyjafjallajökull erupted under its ice cap in 2010, the meltwater and magma reacting together made the blast far more explosive, and the ash grounded European air travel for a week, canceling more than 100,000 flights and stranding around 10 million people. The most disruptive part of the whole eruption never even touched the ground. Ice can drown you or blow you up, but not every eruption is in a hurry. The next one moves at walking pace and still takes everything you own. Hawaiian Eruption, the gentle one that still takes everything you own. This is the volcano from the postcards. Bright orange lava fountaining into the night, glowing rivers of it crossing the ground, people standing close enough to feel the heat and take the photo. Everyone watches it creep along at walking pace and assumes there is all the time in the world. They are right about the speed and wrong about everything else. Hawaiian eruptions run on basaltic magma, which is low in silica and extremely runny. The gas slips out without a fight, so instead of exploding, the lava just pours, glowing around 1,000 degrees and moving like hot syrup. The fountains alone can still reach hundreds of meters into the air. Here is the catch. The flow does not stop, and it does not turn. It buries roads, swallows cars, and grinds through entire houses in a slow, silent crush. You can walk away from it easily. You just cannot take anything with you. In 2018, Kilauea did exactly this on Hawaii's Big Island. Its flows destroyed more than 700 homes and displaced thousands of people without killing a single one. That is the Hawaiian eruption in one sentence. It takes everything you own and it lets you live to watch. But this is the calm end of the scale. From here, the mountains stop oozing and start performing. Strombolian Eruption. Nature playing fireworks with live artillery. From a safe distance, this one is genuinely beautiful. Glowing arcs of lava launching into the night sky on an almost steady rhythm over and over, like a firework finale that refuses to end. People pull up chairs for it. It looks like the friendliest show on earth. Then you work out what is actually being thrown. Strombolian magma is thicker than the Hawaiian kind, so it traps its gas. Pressure builds until huge bubbles rise up the vent and burst at the surface, like a pot of thick sauce boiling in slow motion. Every burst hurls out volcanic bombs, blobs of molten rock that can be the size of a car, hundreds of meters into the air. They come down through roofs and crush whatever they land on. The danger here is not really the heat. It is a straightforward mechanical bombardment, beautiful on the way up and lethal on the way down. It is named after Stromboli, a volcano off the coast of Italy that has been doing this almost non-stop for thousands of years. Sailors used to call it the lighthouse of the Mediterranean because you could navigate by its glow. Fireworks are one thing. The next one buried a city so completely that we are still digging the people out. Plinian Eruption, a skyscraper of ash tall enough to punch through the sky, built to collapse on top of you. People see the eruption column rising far off on the horizon and feel safe because of the distance. It is over there. We are over here. It even looks slow. Physics does not care about the distance. A Plinian eruption fires pumice and ash more than 30 kilometers straight up, drilling right through the stratosphere in one towering column. The danger arrives the moment that column grows too heavy to hold itself up, and gravity wins. The whole thing collapses at once. The sky comes down as a wave of pyroclastic flows, burying everything for kilometers in every direction under meters of scalding ash in minutes. This is exactly how Pompeii ended in the year 79. When Vesuvius erupted, it sealed two Roman cities, Pompeii and Herculaneum, under ash so fast that the people were frozen mid-moment, their bodies preserved as hollow voids we still cast and uncover today. The writer Pliny the Elder died in that eruption, and the type is named after his nephew, Pliny the Younger, who watched it from across the bay and wrote the first scientific account of an eruption in history. And yet, as total as that sounds, it is still not the worst this planet can do. There is one more, and it does not bury a city, it resets the whole world. Supereruption, the planet's reset button and the undisputed final boss of geology. Tourists wander around Yellowstone every summer, photograph the geysers and the bison, and have no idea they are walking across the ceiling of one of the largest magma chambers on the entire planet. That ignorance is a mercy. A supereruption sits at the very top of the actual scientific scale, a VEI 8, the highest rating volcanologists have ever needed to use. When the crust over a chamber like that finally ruptures, it does not so much erupt as empty itself, throwing more than 1,000 cubic kilometers of rock, ash, and gas straight into the stratosphere in a single event. And that is the part that kills on a global scale. All that ash and sulfur spreads around the planet and blocks out the sun, dropping the entire world into a volcano volcanic winter that can last for years. The threat is not the lava or the blast. It is the famine and the cold that follow everywhere at once for everyone. The last true supereruption was Toba in Indonesia about 74,000 years ago. Some scientists believe it choked the sky so badly that it pushed the entire human species down to just a few thousand survivors. For scale, the eruption that caused the year without a summer in 1816, freezing crops across the northern hemisphere and causing famine, was a full step smaller than Toba on the scale.